Hello. Hi. Well, I'm Joey. And welcome. This is the Cancer Fighting book reading today. We're going to be reading today Eat to Beat Disease by Dr. William Lee. And I'm going to show you a picture of him right now. There's Dr. William Lee. And we're going to begin by reading a little bit about Dr. William Lee. And he is the man who wrote the Eat to Beat Disease book that we're going to be reading, part 1, about his 5 health defense systems. So he has 5 different health defense systems, and we're going to learn about them. Let's see. Dr. William Lee. He is a world-renowned physician, scientist, speaker, and author. He is best known for leading the Angiogenesis Foundation. Dr. Lee's groundbreaking work has impacted more than 70 diseases, including cancer, diabetes, blindness, heart disease, and obesity. His TED Talk, Can We Eat to Starve Cancer?, has garnered more than 11 million views, and he has appeared on The Dr. Oz Show, The Martha Stewart Show, CNN, MSNBC, NPR, and Voice of America, and has presented at the Vatican's Unite to Cure conference. An author of over 100 scientific publications in leading journals such as Science, the New England Journal of Medicine, The Lancet, and more. Dr. Lee has served on the faculties at Harvard, Tufts, and Dartmouth Medical School. So that is Dr. Lee. We're going to read Eat to Beat Disease. I'm new to this live, so I'm going to just look here and see if I can, let's see, that might help. All right. Okay. Let's see. All right. I think that's how it will work. All right. We're going to read part 1, Hardwired for Health, Our Body's Natural Defense System. I love when books have quotes and start off with quotes, don't you? I love that. So I'm actually probably going to say this wrong. Not the quote, but the, I'm sorry, not the quote, but the name of the person, which is going to be very embarrassing. But natural forces within us are the true healers of disease. So natural forces within us are the true healers of disease by Hippocrates. Hippocrates. Okay, I'm going to say that wrong. That's so terrible. Next time I will have that correct. Okay, let's begin. Health is not simply the absence of disease. Health is an active state. Your body has within it 5 health defense systems: angiogenesis, regeneration, the microbiome, DNA protection, and immunity. These systems are responsible for maintaining our health and resisting the regular hazards we all face every day as a part of ordinary life. And they heal us when incursions from disease inflict damage in our body. By knowing about how these systems defend your body like a fortress, you can tap into their healing powers to live a longer and healthier life. Each of your health defense systems has a fascinating story of research and discovery. Each is supported by a well-orchestrated symphony of players: organs, cells, proteins, and more. Each is a common denominator for preventing not one, but many diseases. And all 5 systems work together to keep you in great health, from the time you were in your mother's womb until your last breath. Join me in the next 5 chapters, which we'll do over the next 5 Sundays, to get to know these systems and the benefits they can offer. So, chapter 1, angiogenesis. So we're going to begin. We all have cancer growing in our body. Every single one of us, even you. In autopsy studies on individuals who never received a diagnosis of cancer during their lifetimes, almost 40% of women between the ages of 40 and 50 had between 50 and 60 had microscopic cancer in their prostate, and almost 100% of people over the age of 70 had microscopic cancers in their thyroid gland. I'm going to repeat that actually. Almost 40% of women between the ages of 40 and 50 had microscopic tumors in their breasts. About 50% of men between 50 and 60 had microscopic cancer in their prostate, and almost 100% of people over the age of 70, this is amazing, over the age of 70, had microscopic cancers in their thyroid gland. Tumors such as these develop when healthy cells make natural errors during cell division, or when a cell's DNA is mutated by environmental exposures. Up to 10,000 mistakes occur in the DNA of dividing cells in your body every day, making the formations of cancers not only common but inevitable. And yet these microscopic cancers are completely harmless. Most of them never become dangerous. They start out tiny, smaller than the tip of a ballpoint pen. Yeah, here's a ballpoint pen, tinier than the tip of a ballpoint pen. And as long as they cannot enlarge and invade organs, they cannot spread and kill. Your body has a remarkable defense system that keeps microscopic cancers small by starving them of the blood supply and nutrients they would need to grow. And you can optimize this defense system through the foods you eat. More than 100 foods can enhance your body's ability to starve cancer and keep those tumors small and harmless. Among them, soy, tomatoes, black raspberries, pomegranate, and even some surprising ones like licorice, beer, and cheese. Your defense weapons to keep these tumors at bay can be found at the grocery store, the farmer's market, and in your garden. I don't think he's talking about processed cheese by Kraft, though, so just keep that in mind. You may not like cheese anymore once you have the real cheese. I'm just kidding. Okay. The defense system that allows our bodies to intercept cancer this way is called angiogenesis. So the defense system that allows our bodies to intercept cancer this way is called angiogenesis. And angiogenesis is the process our bodies use to grow and maintain blood vessels. In ordinary circumstances, blood vessels are supporters of life, delivering oxygen and vital nutrients to all of our organs. But when abnormal blood vessels grow, they can nourish microscopic cancers. A healthy angiogenesis system regulates where blood vessels should grow and can prevent tumors from recruiting a private blood supply for the oxygen they need to expand. When the body loses this ability to control blood vessels, a wide range of diseases can occur, including cancer. As long as the angiogenesis system operates properly, blood vessels grow in the right place at the right time. Not too many, not too few, but just the right amount. Keeping this perfect balance in the circulatory system is at the heart of how angiogenesis defends health by keeping us in a state called homeostasis. Homeostasis is defined as maintaining stability in the body for normal function while adjusting to constantly changing conditions. Angiogenesis plays a vital role by creating and maintaining your entire circulatory system and adapting it to various situations over the course of our lives to protect our health. Because of this powerful health defense system that naturally cuts off the blood supply to tumors, cancer doesn't have to be a disease. In part 2, I will show you how the latest science of angiogenesis is shaping our understanding of which foods can help your angiogenesis system maintain homeostasis, and how you can eat to starve cancer, grow vessels to feed your heart, and stave off deadly diseases to live a longer, healthier life. But in order to fully appreciate how food influences angiogenesis and your health, let's first take a look at how blood vessels go to work for you every day. Angiogenesis at work. Inside you, there are 60,000 miles of blood vessels whose job it is to deliver oxygen and nutrients to keep cells alive. These are the vessels of life that nourish our healthy organs and protect us against disease. If all your blood vessels were lined up end to end, they would encircle the earth twice. Remarkably, it takes only 60 seconds from the time your heart pumps out a drop of blood for it to circulate through the body and back again. The smallest blood vessels are called capillaries. They are finer than a hair, and your body has 19 billion of them. Capillaries have a unique relationship with all the other cells because they are the final link in the chain of the blood vessel delivery system to your cells. Because they are at the end of the line, virtually every cell in the body is located within 200 micrometers from a capillary. That's really close proximity, just a little more than the width of a human hair. Each organ has its own unique density and pattern of capillaries, depending on what the organ does and how much blood flow it needs. Your muscles, for example, have a huge oxygen demand, So they need 4 times more blood supply than your bones, which act as a structural support. Other high-demand organs for blood flow are your brain, heart, kidneys, and liver. All of these have a capillary density of an amazing 3,000 vessels per cubic millimeter, which is 30 times that of bone. Under the microscope, capillaries look like works of art, sculpted to fit the organ in which they are growing. The ones feeding your skin look like rows of Velcro hooks with loop after loop of vessels providing the blood that gives warmth and color to your body's surface. Along your nerves, oops, my dog does not like the noises he's hearing. That's Charlie. You might have seen him in some of the videos. He might bark a little bit here right now, but hopefully not. Charlie, nope. Okay. Along your nerves from the spinal cord to fingertips, capillaries course along the telephone lines, feeding neurons and keep your senses sharp. In the colon, capillaries are formed in a beautiful geometric honeycomb pattern so that they can stretch with the colon as it fills with digested matter, while providing maximum surface area to absorb fluid back into your bloodstream. The importance of angiogenesis to support life is so fundamental that it begins in the reproductive system, even before conception. By the time a sperm meets an egg, the womb has already been prepared with the endometrium, a lining of new blood vessels ready to receive and nurture the fertilized egg. If no pregnancy occurs, this lining is sloughed off every month during menstruation. If the fertilized egg is implanted, the blood vessels act as the first supply lines for the developing fetus. About 8 days after implantation, a new vascular organ, the placenta, is created to bring blood from the mother to the fetus. Over the next 9 months, a symphony of angiogenesis takes place within the fetus, forming an entire circulatory system from scratch, and then filling up each organ in the developing body. Toward the end of pregnancy, as the body prepares for birth, the placenta releases a natural angiogenic factor called soluble FLT-1, which slows down the building of blood vessels. This ability to turn on, turn down, and turn off is a hallmark of the angiogenesis health defense system, not only for building life during pregnancy, but for protecting our health during life's duration. Angiogenesis defense is a method to protect all animals with a circulatory system, including humans. Whenever you've suffered a deep cut, whether from surgery or trauma, you've no doubt noticed the wounded area starts to undergo changes within seconds, launching a process that continues until the wound is healed. If you've ever scraped your knee badly enough to bleed and later form a scab, and if that scab pulled off too early, you have seen this process unfolding right before your eyes. Underneath the scab, the tissue was bright red and glistening. In that red patch, thousands of new blood vessels were growing in the wound to restore the injured tissue back to health. When you see this process, you are witnessing angiogenesis, which is jump-started in wound tissue as soon as bleeding begins. The trigger is hypoxia, or lowered oxygen levels, caused by the interruption of normal blood flow in the injury. Lack of oxygen is the signal for more blood vessels to grow to bring in more oxygen. Hypoxia causes wounded cells to start releasing protein signals called growth factors, whose job is to stimulate angiogenesis. Inflammation is very important at the beginning of healing. Inflammatory cells called macrophages and neutrophils crawl into a wound to clean up any bacteria and debris from the injury, and they themselves release their own angiogenic growth factors, amplifying the blood vessel generating response. From here, several events unfold on the cellular level to grow blood vessels. Thanks to special linings, your veins called endothelial cells, a rescue team is waiting to receive the growth factor signals that instruct the endothelial cells to deploy. Roughly 1 trillion endothelial cells line your circulatory system, making them one of the most abundant cell types in your body. Think of each of these endothelial cells as a car engine connected to an ignition switch. Now imagine the growth factors that were released from the site of the injury as car keys. The growth factors fit into specific receptors studding the surface of endothelial cells just as the car keys fit into ignition switches. When the right key goes into the right switch, the engine turns on, and the endothelial cells are ready to start migrating towards the source of protein growth factors, and start dividing and forming tubes that will turn into new blood vessels. But first, the endothelial cells need to get out of the vein. They release enzymes that digest the sleeve wall of the vein outside of the cell, creating holes in the vein wall. From this point on, The activated endothelial cells begin sprouting out of these holes, following the gradient of growth factors being sent from the injured area and building new blood vessels in that direction. It'd be cool to have pictures of things like this. I'll have to figure out how to use streaming software and stuff to think you can add in images and things like this. As blood vessel sprouts elongate, they roll up lengthwise to create tubes, and tubes eventually connect at their tips to form capillary loops. As more and more capillary loops form in the healing zone, a new circulation for healing is born. Freshly formed blood vessels are way too fragile to support blood flow on their own, so they are assisted by another type of cell, the pericyte, which helps them mature. Pericytes help out, not parasites, but pericytes help out in a couple of ways. Pericytes. T-E-S. First, they wrap themselves around the endothelial tubes like a tube sock over an ankle to provide architectural stability. Simultaneous, the parasites slow down angiogenesis so there isn't a super overage of blood vessels. The parasite cells are shapeshifters. Once anchored to a new blood vessel, they extend tentacle-like arms to embrace the endothelial cells around them. A single parasite can touch as many as 20 cells at a time and release a chemical signal that turns off the frenzied activity surrounding angiogenesis. Once the new vessels have sprouted and been stabilized, blood flow begins. The flood of new oxygen turns down the switch for growth factor signals, slowing the engines of angiogenesis until they finally grind to a halt. At the same time, natural angiogenesis inhibitors are released in the area, further suppressing new blood vessel growth. When the new blood vessels are solidly in place, the endothelial cells lining them churn out proteins called survival factors that help heal cells in the neighborhood where angiogenesis took place. When properly constructed, these defensive new blood vessels can last for a lifetime, keeping the skin and other organs alive. The angiogenesis system constantly senses where and when more blood vessels are needed to help keep organs healthy and functioning. Like a master builder, blood vessels detect the need from your muscles after a workout. More blood flow is needed to build the muscles. On the other hand, the system is also constantly on the lookout for situations where blood vessels should be pruned back. Not too few or too many, but just the right balance and mix of blood vessels is what a healthy angiogenesis system is designed to accomplish 24 hours a day. It's like a dimmer switch. The intensity can be upped to grow more blood vessels when there's a need, and when it needs to be dimmed, your body has endogenous, naturally occurring in the body, inhibitors of angiogenesis that squelch the process. These stimulators and countermeasures are everywhere, including our muscles, blood, heart, brain, breast milk, and even semen. Your body's control of angiogenesis needs to be perfect to optimize your health. Over the course of a lifetime, however, many factors can derail this defense system, leading to either excessive angiogenesis, which can feed the diseased tissues, or on the other hand, insufficient angiogenesis, which can lead to tissue loss and death. You're going to learn about the foods that help shore up your angiogenesis defense to help your bodies resist diseases in part 2. But first, let's return to the microscopic cancers growing in your body to see how breakdown of the defenses happens and its dire consequences, so you can learn why it's important to eat the right foods for health. The main reason microscopic cancers don't grow is your body's natural angiogenesis inhibitors. These countermeasures keep tumors in check by depriving them of blood supply. As research at Harvard Medical School discovered as early as 1974, so long as no blood vessels grow to feed tumors, the cancer cells will remain dormant and harmless. Your immune system, which I'll tell you about later in Chapter 5, eventually spots them and destroys them. Over time, however, some tiny nests of cancer can overwhelm the defense system and overcome angiogenic countermeasures by releasing huge amounts of the same growth factor signals involved in wound healing. In lab experiments, once new blood vessels sprout into the small cluster of cancer cells, a tumor can grow exponentially, expanded up to 16,000 times in size in only 2 weeks after angiogenesis starts. When tumors hijack the angiogenesis defense system to grow their own circulation, a harmless cancer quickly becomes a potentially deadly one. Worse yet, the same blood vessels that feed cancer tumors also serve as exit channels for malignant cells to escape into the bloodstream. This is known as metastasis and is the most dangerous aspect of cancer, where cancer starts spreading. Patients with cancer rarely die from their initial tumor, which can often be removed by surgery, unless, of course, Like me, you have blood cancer, which is not removable by surgery. But it is also a tumor-like, they're liquid tumors, so it's interesting. So patients with cancer rarely die from the initial tumor, which can often be removed by surgery. It's the metastasis that pepper the body like buckshot that kill. So it's the spreading of the cancer that they can't keep up with removing all these parts of the body. So helping the body prevent unwanted angiogenesis can have the powerful effect of suppressing cancer. The goal is to boost your angiogenesis defenses, helping your body's natural countermeasures keep blood vessels in the normal zone of balance, which means cancer cells do not have the advantage of being fed, so they can't grow. The first patient to benefit from anti-angiogenic treatment was a 12-year-old boy named Tom Briggs who lived in Denver, Colorado. He was diagnosed with a condition called pulmonary capillary hemangiomatosis, in which tumors grew in his lungs. As the tumors expanded, his breathing became difficult and it interfered with his ability to play his favorite sports, like baseball, and sometimes to even get a good night's sleep. As a last-ditch measure, he received a medicine called interferon alpha, which his doctors knew could stop angiogenesis. Over the course of a year, his lung tumor shrank away and Tom returned to living a life as a normal kid. Tom's case was so remarkable that it was published as a first human case in the New England Journal of Medicine as a glimpse into the future of treating tumors. One moment, I'm going to change my lighting here. See if I can anyway. Sorry about that. Well, that will be the best I can do today, but we'll work on this. So biotech companies began developing targeted drugs to treat tumor angiogenesis starting in the 1990s. The first cancer to show the benefit of anti-angiogenic therapy was colorectal cancer, where targeting tumor blood vessels improved patient survival using a treatment called Avastin. Many other cancers have become treatable by boosting the body's own angiogenesis countermeasures using Avastin and more than a dozen other designer medicines that inhibit angiogenesis. These include kidney, lung, brain, thyroid, liver, cervical, ovarian, and breast cancers, as well as multiple myeloma. In 2004, U.S. Food and Drug Commissioner Mark McClellan declared, angiogenesis inhibitors can now be considered as the fourth modality of cancer therapy, after surgery, chemotherapy, and radiation. Charlie, we're doing a reading. No. Sorry about that. I have to edit this out. I'm sorry you have to listen to this during the live. Okay. Shh. No barking. We're doing a reading. No. He grumbles when he barks. Wish you could see him. He's very cute, but okay. Excess work. We've got just a little bit more to go, and there's some interesting information coming up. So hang in there here. Excessive angiogenesis drives disease in many other conditions beyond cancer, such as vision loss. In the healthy eye, vision is possible because light can pass through crystal clear fluid to the retina and be registered by the brain without interference from blood vessels. Charlie. Angiogenesis in the eye is so tightly controlled that the endothelial cells lining the blood vessels in the retina normally divide only twice in a person's lifetime. Whoa. Charlie, please. No. Okay. But in both age-related macular degeneration, AMD, the leading cause of blindness worldwide in people aged 65 and older, and diabetes-related vision loss, angiogenesis leads to abnormal tangles of blood vessels being formed, which leak fluid and bleed. This disastrous consequences of unwanted angiogenesis destroys vision. Fortunately, these conditions can now be treated using FDA biological medicines that are injected by ophthalmologists into the eye to halt the destructive angiogenesis, stop the leaking, and protect vision. Some patients can even regain lost vision. I had one patient who became legally blind from macular degeneration and could not drive or play golf, her favorite pastime. After treatment, she could safely drive again and got back to working on her backswing on the golf course. In both rheumatoid arthritis and osteoarthritis, inflammation in the joints leads to new blood vessels that release destructive enzymes. These enzymes destroy your cartilage, which causes crippling joint pain. In psoriasis, a disfiguring skin condition, abnormal angiogenesis under the skin helps grow the patches of raised red skin plaques that are accompanied by swelling, irritating itchiness, and pain. So it has to do, angiogenesis has a lot to do with many things, cancer included. Alzheimer's disease has been discovered to involve excessive and abnormal angiogenesis. In 2003, along with psychiatrist Dr. Anthony Vagnucci, I proposed that abnormalities in brain blood vessels contributed to Alzheimer's disease in a paper that was published in The Lancet. Not me, but Dr. William Lee. Today, we know that blood vessels in Alzheimer's affected brains are abnormal and do not actually improve blood flow, but instead they release neurotoxins that kill brain cells. Even obesity has a powerful angiogenesis connection. Although obesity is a multifactorial disease, overeating and eating the wrong foods generate high levels of angiogenesis, stimulating growth factors circulating in the blood. Just like tumors, a mass of fat requires new blood vessels to grow and feed fat cells. For all of these health concerns and many others, exciting new angiogenesis targeting drug treatments are showing promising results in the laboratory and in clinical trials. And also foods, as you'll learn later. Pruning away excessive blood vessels is important, but just as important is maintaining the body's capacity to grow an adequate circulatory system to protect organs that need to increase or restore their blood supply. As we age, our circulation often naturally wanes, and this ability needs to be coaxed and boosted to feed and maintain healthy tissues and organs. When compromised, the inability to mount a defensive angiogenic response has dire consequences. One such consequence is neuropathy. Neuropathies occur when the function of your nerves is compromised. This can lead to numbness or pain that range from mild to crippling. Your peripheral nerves are your electrical wiring run throughout your body, relying directions from your brain to your muscles, telling them to contract and relax. The nerves also send sensations from your skin and muscles back to your brain. These electrical cables have their own mini circulatory system called the vasa nervorum, which keeps blood flowing to nerves. When the vasa nervorum goes down, nerves begin to die. The symptoms can range from tingling to unbearable pain to complete numbness of the hands, legs, and feet. People have this a lot with chemotherapy as well during treatment. So people with diabetes can develop a compromised nerve blood supply, especially if their blood sugar is not well managed. Diabetes also slows down angiogenesis, which damages nerves. Researchers have been working on new ways to improve nerve blood flow using therapeutic angiogenesis. In the lab, researchers inject the muscles of diabetic animals with the gene for the angiogenic protein VEGF, vascular endothelial growth factor, and find they can increase blood flow to the nerves and restore their function close to normal levels. Wow. So they're helping to treat diabetic animals. Another common cause for peripheral neuropathy is cancer chemotherapy, which we just mentioned, which not only kills cancer cells, but can be highly toxic to nerves and destroy their mini circulatory system. In the lab, gene therapy using VEGF completely protects the nerves and their blood supply against the loss of function. When your angiogenesis defenses are crippled, many other diseases can intrude in your life. Chronic wounds are another example. While normal wounds heal in under a week's time, chronic wounds are slow to heal or don't heal at all. These open sores become infected, gangrenous, and often lead to the need to amputate an affected limb. This affects more than 8 million people in the United States alone, specifically striking people with diabetes, atherosclerosis, or malfunctioning valves in their leg veins, or those who are confined to bed or use a wheelchair. It's a silent and deadly epidemic with a mortality rate greater than breast and colon cancer. Wow. If you have a chronic wound, one of the primary goals of your doctor should be to jumpstart angiogenesis to improve blood flow and speed up healing. This can be done with a variety of medical devices and other techniques, including diet. We'll talk about angiogenesis stimulating foods in chapter 6. Your heart and brain also rely on their angiogenesis. He also does a little bit before we go here a little bit. We mentioned some diseases. Your heart and brain also rely on the angiogenesis defense system to respond whenever there is any threat to their own circulation. Restoring blood flow quickly to these organs is literally a matter of life and death. When there are blockages to their blood vessels, which happens with atherosclerosis, your defense systems will kick into gear and grow new blood vessels to help form a natural bypass around the blocked channels. Natural bypasses, called collateral vessels, form when the blockages occur slowly with gradual narrowing of the coronary vessels or carotid arteries. People can live for years or decades with their coronary heart disease or carotid disease if their angiogenesis defense system does its job. Even in the case of sudden blockages, such as happens with a heart attack or an ischemic stroke, if the patient survives, the angiogenesis defense will kick in to form natural bypasses. So angiogenesis has a lot of important functions. This defense happens slowly if a patient has a condition that stymies angiogenesis, such as diabetes or hypercholesterolemia, or is a smoker, or is elderly. Clinical trials for therapies that stimulate angiogenesis in the heart or brain have shown it is possible to deliver new therapies to speed this process, but these are still in experimental stages and years away from being used to treat patients. In part 2, I'm going to tell you about the foods that you can use at home to aid cardiovascular angiogenesis and healing. That's probably the part we should be reading. Foods and angiogenesis. Clearly, a fully functioning angiogenesis defense system protects us against many diseases. Your health depends on the normal balances of circulatory system without excessive or insufficient blood vessels on your organs. When this balance is upset, your body needs help. Research at biopharmaceutical and medical device companies are racing to develop new life, limb, and vision-saving treatments. But creating a new therapy can take a decade or more, cost more than $1 billion, and even if successful, may not be accessible to everyone who needs it due to the cost and availability. Even more, these drugs and devices are intended for disease treatments, not prevention. Your diet can be used for disease prevention as well as to help aid treatment. Your diet can be used for disease prevention as well as to help aid treatment. Research being conducted from all corners of the world is revealing that specific foods and beverages, including many that we recognize and enjoy, can boost our angiogenesis defenses on both sides of the equation. Even the way you prepare and combine food ingredients can influence angiogenesis. This brings an entirely new perspective to how to think about foods you eat and how to eat them. And it opens new doors if you want to increase your odds for preventing diseases influenced by angiogenesis. If you are currently battling an angiogenesis-dependent condition, choosing the right foods may help you control or even beat that disease. There's mounting evidence for the power of this approach. People in Asia who consume lots of soy, vegetables, and tea in their diet have a significantly lower risk for developing breast and other cancers. In Japan, there are more than 69,000 people who are older than 100 years of age. China also has a rising population of centenarians. My great-uncle, who lived to a healthy 104, resided in the town of Changshu, outside of Shanghai, at the base of Yushan Mountain, where green tea is grown. The vibrant centenarians of Icaria, Greece, and in central Sardinia eat the Mediterranean diet, which is chock full of angiogenesis defense-boosting ingredients and not strictly vegan. Understanding that angiogenesis is one of your key health defense systems is key to unlocking new secrets for long-lasting health inside your body and outside of the healthcare system. Thank you for listening. I'm now going to read you conditions where angiogenesis defenses are breached. So, where there is too much excessive angiogenesis is in the following conditions. This is where there's too much angiogenesis: age-related macular degeneration, Alzheimer's disease, brain cancer, breast cancer, cervical cancer, colorectal cancer, diabetes-related vision loss, endometriosis, kidney cancer, leukemia, liver cancer, lung cancer, lymphoma, multiple myeloma, obesity, ovarian cancer, prostate cancer, psoriasis, rheumatoid arthritis, and thyroid cancer. Lymphoma cancer, leukemia cancer. So, insufficient angiogenesis. This is where there isn't enough angiogenesis. These are the conditions that are affected by that. Alopecia, so where you have a lot of the hair loss. Diabetic foot ulcers, erectile dysfunction, ischemic heart disease, heart failure, neuropathy, peripheral arterial disease, peripheral neuropathy, pressure ulcers, and venous leg ulcers are all insufficient angiogenesis. Well, thank you very much for listening to part 1, chapter 1 of Dr. William Lee's Eat to Beat Disease. I'm actually thinking we possibly will read part 2 because it might be more interesting to people. and we might get more to the nitty-gritty of the foods, but I wanted to take a look at the beginning of Eat to Beat Disease by Dr. William Lee. Thank you very much for listening, and have a very good and blessed evening. Thank you.